Evening, class. Hope everyone's going good after rock, paper, scissors, lesson 4. There's been a couple issues with that. A lot of folks didn't use functions or custom functions. Note to self, use what's in the week's lesson to get points. It's a build on build technology here. Things we cover week 1, use in week 2, week 3, week 4, all build on build. Week 5, it may seem like we're regressing. We're going back to learn about iterating through strings, slicing and dicing strings, testing and searching, manipulating strings, and exception handling. Wild thing about all this stuff is if you can control an object at the smallest level, a string, you can iterate through larger objects. You can slice larger objects. You could test and search for larger objects if you could find a small one. The technique doesn't change, just the scope of what you're searching does or what you're trying to manipulate. So without further ado, let's dive right into it. So hit F5 on this. So I just went ahead and ran this. You see that our variable set to fruit, string banana. This is called indexing, or we actually look at the indice of each individual string or character that makes up this string banana. So variable called first letter, fruit, followed by square brackets, index of 0 would give us B. B is in the 0 index. And when we print the first letter, there we go. Super handy to see if there's a leading space. You could run tests on sentences or paragraphs to see if there's a space or a tab or something odd in the beginning of a line. Some CSV files come with this weird symbol that you sometimes want to find and remove. And you guessed it, to do the complete opposite, to grab the last character in our string, we call the indice of -1. And we store it in last letter or last object, and we get an A. This is awesome for stripping off the last piece or copying it into a variable called last object or last string to see if it's a punctuation, a space, a hard return, and then you can do some checks that way as well. So that's super handy, right? Let's see what else we got here. I'll skip that. Yeah, this won't work. Calling on indices of floats, not a thing. They're whole numbers. 0, positive numbers, or negative numbers. That's it, right? So here's an oldie but goodie. We got our length function on our fruit variable. Well, when we store it in a variable called length, we print length, we get 6. Banana indeed has 6 characters in it, 6 strings, 6 objects. The length of fruit is 6. Pretty self-explanatory there. And we're going to stick with banana for a minute. We're going to do a for loop. So we're going to iterate through a string without creating a list or anything. It's unnecessary, right? Because itself, a string is an iterable object. So what does that mean? Well, you can iterate through it. So you could call in the indexes. For each character in my fruit, print the character, follow with a dash. So we're not doing the stereotypical hard return. We're just saying dash. So B, follow with a dash, A, follow with a dash, and so on and so forth. Pretty cool stuff, right? So that's some cool stuff as far as indexing and iterating through a string. It's kind of self-explanatory. Now we get into some fun slicing. Slicing is a bit more similar to a range, except you'll see here that we create a variable with a string of Monty Python. We print the name, and that's right here. And then we name and we call in the indices starting at 0, stopping at 5. 0, 1, 2, 3, 4. 5 is the space. So we stop there, right? Now, here we pick up at 6 and go to 12. Yeah, we got Python. Now, you could do things, you say, well, when would I ever do this? Well, first parts of IP addresses, things of like a MAC address, a layer 2 address. The first 6 are often what's called the OUI, which is the manufacturer company that made the actual the NIC itself, the chip on the NIC. So here you could say MAC 0 through 6, store it in OUI and print the OUI. And here you have the first 0, 1, 2, 3, 4, and 5. Pretty handy. That's a real life scenario. Sometimes you have to pull the MAC address, right? And this is called slicing, by the way. And a way to start from the beginning and go to 3. If you don't want to put a 0, you don't have to. You can just put a :3. A 0 is implied. It'll start from the beginning and go 3. Stop at 3. Got your band. This starts at 3, and then very similar, it goes to the end. Starts at 0, 1, 2, 3, and goes to the end. Awesome. Now you'll get a null example. If you start and stop on the same index, you get nothing back. Null example, right? Let's check out a sentence, right? Exclamation, right? 'Tis but a flesh wound, we store it in sentence. Print the sentence, we got it here. Now we start slicing, -2 to the end. So it goes -2 to the end, and you get your D exclamation point. Now this is cool. -6 to -1. Well, count back -6. We go and stop at -1. We get wound. Start at the end, or start at the beginning, go to -15. Let's see, is that correct? Yeah, 'tis but. So we start at the beginning, go this way, but then we go back 15, and this is what we get. 'Tis but. So you kind of get the gist of this, right? Now, here's a start, stop, and step, just like a range. Start at the beginning, stop at the end. Give me every 2 objects, every second objects. So here's that fun stuff. And here's start at 1, so it's skipping the T. Start at 1, go to the end every third. You can do some pretty fun stuff. If you're looking for obfuscation, some odd stuff and malware, sometimes this helps, right? So there's all kinds of fun mastery of the string. And like I said, if you can master the string, you can master larger objects. So here we have another variable called greeting. Hello. Now we're going to call on greeting starting at 1, going to the end. And we're going to J plus 1 to the end of greeting. So it should say Jello World, right? And that's exactly what we get. Jello World. That's our new greeting, old greeting. How many A's are in banana? This is pretty common. Word, banana, count set to 0. For each letter in my word, if L equals A, add 1 to the counter. For B in word, false, A true, N false, A true, N false, A true, counter equals 3. Awesome. This is probably one of the most powerful operators that are overlooked, in and not in. So here you can say A in banana, true. Python goes A in banana, B no, A true. It does not keep going. The first one it finds, it stops because it's true, right? Seed in banana. Well, four character test, 4-character test, 4-character test, 4-character test. No, false. A not in banana. Of course, it's false. Same thing. First one it finds, not in, false. C not in banana, true. It's not in. In is an extremely overlooked, and it's not used enough. If you have a long list of things and you want to see if this is in that list, in is where it's at. In helps you more than I could ever tell you. It's an absolute fantastic small operator. Overlooked. So this is a little longer. Let's run it. I don't know, it'll break somewhere. We'll give it a try. So back to our word and banana. If A in word, print we found an A, else print no spoon. Well, A in word, first one it finds, true. Print we found an A. Cool. Dessert equals banana pie. If pie not in dessert, no pie for you. Else we're having pie. That's misspelled. So is that tonight. Well, guess what? Pi is in there. We're good to go. So now we're moving down to here, right? Word is banana. If word is equal to banana, I'll write bananas. So you could do whole word comparisons. Same operators as before. Equal to is equal to, right? Works out awesome. For banana less than Z, print word plus becomes Z, right? You can follow the logic on here. Banana comes before Z. Well, why is that? How does it know? Alphabetically? It's the ASCII value or the Unicode value of the first letter. So B is less than Z. It comes before. Awesome. Fruit, banana, dessert, pie. Here is some addition. Remember, they're like objects. They're both strings. So you can add them together. But when you add them together, you get no space. Neither of these objects have a space in the string, and a space is considered a string when it's wrapped in quotes. So here we have banana ending with the space. We add them together, we get our space from banana. Here we get our space from pie. Cool. So let's build banana. Fruit equals B. Now this is just like a counter. Fruit plus A. So B plus A. BA plus N. BA N plus A, and so on and so forth. And you build banana. But you notice that this print fruit has spaces because the separated value of print was the space of each object. So you could change that by just adding the sep value here equals nothing. Easy stuff, right? And move right along. Here we have banana, pie, plus or minus, so fruit plus pie, print. Once again, no spaces. There we go. So now we could replicate strings. Simple. As long as it's the same value, high, in our greeting, times 5, you get it times 5. Python will help you repeat strings. Now we're going to talk about some different methods of a string. Methods of a string are functions of a class. If you take exactly like stuff and print type of stuff, you see it's a string. The type comes back as a class. Well, the object type is a string. So here we do a dir on stuff, and these are all the fun-filled methods or functions of a class that you could perform on a string. Is lower, is numeric, is join, is upper, left justified, right justified, strip, all this fun stuff. And there's a lot of them. We'll take a look at a couple. Is alphanumeric? Awesome. This is an awesome one, right? Here we have banana 7. Print string. Call on our variable. String is our variable. It is a string class object. Is alpha numeric is a function of the class, so a method. And here we say string is alphanumeric, and we get true because it is indeed alphanumeric. Is alphanumeric? False. There's a special character in here, a space, not alphanumeric. Is alpha? We got just banana. Is alpha? True. So you start to see a trend here. We get booleans back. So we could grab a lot of text or a lot of strings and check to see if there's punctuation in it relatively quickly because they're special character. Is alphanumeric? False. We know something in the string is not an integer or not a known character. So in other words, you have to hold down shift and press something, right? So banana is alpha. What do we get here? We get a false. And we print the word banana. Now this is cool because we get upper. So upper does what? Well, takes it all uppercase. Capitalize, the method of capitalize. You guessed it. We give it a weird looking banana. Capitalize just capitalizes the first letter. Super handy. if you're building a web form, taking in user input and first name, last name, I always type all lower. Why? I assume on the back end they changed to capital or maybe to all lower, so I never put a capital Z or a capital W. Capitalize will fix that if you're building a web form and you need that capital letter up front. So we got C12, banana all wild, and we say word capitalize. You notice it just capitalize the C here. It doesn't capitalize the second word. It sees this as one word or one object. And it just, our variable name happens to be word. Capitalize will only capitalize the first lowercase string that is non-alphanumeric. So here we have upper test, print upper test for right here. And now is upper. It does a check to see if your string is all upper. And here we get a false because it is not all upper. Cool. Strip method. You see that there's a beginning and ending space here. When we call it a variable strip, it removes those spaces. Cool. Left strip removes just the left one. You see that there's a space at the end right here. Right strip, now check this out. Now we're saying line, our strip, they were given it. We're actually calling out a parameter, giving an argument saying, hey, end with it. You know, if it ends with an O, remove it. And that's exactly what it does. Cool stuff. Here's another one that's up there with in and not in. Find. So here we have banana back at fruit. We say fruit find A, and guess what it gives you? It gives you back the first index it finds. It finds it in index 0, 1. And it gives you back the first and only one, because we didn't iterate through it. We said find A, it's found the first A, and it was done. Helpful, right? Now, the replace method. We're going to say, here's A, replace it with I. Banana, banana replace A with I, print my banana, and we get banini. Cool. Replace takes 3 arguments. Replace A with I, but only do it twice. Banini, banini, banina. You get it. So here we have starts with, super handy method. Starts with please, true, gives you back a Boolean. So you could check if things start with or like here we say starts with lowercase p and we get a false because it's a capital P. Right? And here we say starts with have 7. Ooh, so now starts with, we can give it a string that we're looking for and a start indice. 0, 1, 2, 3, 4, 5, 6, 7, have. True. Pretty handy. If you know a roundabout index of what you're looking for, right? Pretty handy. And of course, we have starts with, we have ends with. Here we have a nice day, ends with Y. You guessed it, you get it true. And you can also chain methods. So here we have, please have a nice day. Now, the order of operations matters here. If you flip these, this wouldn't work. Line, lower, so all this goes to lowercase. And now does it start with P? True. If we were to run this one, line starts with P, we'd get a false, and then we'd lower. Not helpful, right? I'll run that in a second. And then you can also split strings. Here we have lesson 5 lab pi all separated by a comma, and we give it a delimiter. We say split our variable, call our variable, the split method, and we give it what to delimit on, the comma. And then we print our words, and we come back with a list of lesson 5 lab pi, 0, 1, 2, 3, individual objects in a list. Extremely handy. Let's see what we got here. think that's quite a bit. The replace function is your friend. Do not use CHR or ORD, character or ordinal. No need. Don't do that. Don't use them. Do not use them for this lesson. I will mark it wrong, give it a 0, and turn it back to you. Use what's in the lesson. These are the powerful tools that you're here to master, not something you looked up on the internet that is incorrect. These are actually methods of a string class. They are not a character checker or ordinal number for Unicode values. So let me change this again. I told you I would, so let's do this. And you'll see at the very end that it broke because the bool object has no attribute of lower. We said line starts with P, and this comes back a false, which you cannot send false lower because the object false is a Boolean object and it has no attribute of lower. So keep that in mind. Big difference, order of operations matters. Remember the type of object that you're trying to manipulate matters. And that is it for this evening. Next week, I think we're on break next week, I believe. I think we are. So that's good news. So you get some extra time to relax. Probably well deserved after your midterms. But we'll revisit this. We'll see you when I see you. So enjoy your break and have a great rest of your day. Goodbye.